Hello, my name is Ralf Rantzau. I'm with the OpenStack team at Cisco, and today I'll talk something that is more on the data-related side, not so much on the stack-oriented side. I'm talking about Ceilometer, or more in general, metrics or telemetry data, and how we can process such data using SQL over something that is not available currently in OpenStack, but hopefully in the future, data streams. So Ceilometer data, I'm just going to brush this very quickly here. Ceilometer data entails measurements from different types of components of OpenStack: storage, compute, identity, networking, and so on. And users can also add the measurements if they have additional, maybe more application-oriented data. And the Ceilometer architecture, this is taken from the OpenStack website. I just want to highlight here, there is a column here that you see. It's called databases. This is kind of the data sink for all the information that comes from the pipeline that provides the actual metrics, in this case, polling agents, notification agents that feed into collectors and then into databases, which then serve downstream applications, for example, for analytics. Another illustration that I stole just shows the options that you have for storing your data in OpenStack. SQL database here on the right is one alternative. The default is MongoDB. However, if we would replace SQL database with one that enables data streams, you will see the advantages that I'm going to talk about for the rest of this talk. So why streams? Why not deal with what we have already? Databases. Streams enable you to do live versus historic comparisons, also live versus live in a sense. I look at something that happens and compare it with something else, maybe logs compared with metrics, or certain CPU metrics with storage metrics, similar things. Roll up and drill down are terms that I borrow here from the data warehousing world, where you can build hierarchies to analyze data on different levels of granularity. For example, the time dimension here reflects granularities of minutes, an hour, and so on. And you can imagine that metrics also are connected to the actual location where they spring from, where they come from. For example, the nodes, the racks, and the data centers where OpenStack is deployed. So another view that why streams are really useful in this OpenStack world is it also deals with on-the-fly ETL, extraction, transformation, load, another data warehousing term, where you do transformation in flight as opposed to an offline process that is usually done using a lot of storage. You can do a lot of transformations while the data is still fresh and feed that into destination downstream systems. So here's some sample data. You see here only 3 columns. I simplify a few things. Sample data for a data stream could be a time dimension here, where you see the timestamps where the metric was detected, the name of that metric or measurement, and the value. Here in this case, it's all integers. It could be floats or similar values. Notice that in traditional databases, we're dealing with tables. With data streams, we have an unbounded sequence of rows similar to an open-ended table, an append-only table in a sense. And what you see here on this slide is that I group certain elements in the stream and consider them as a table internally in the system in order to do analytics, aggregations, or other things on this chunk of data. Different window operators we can deal with in a stream system. For example, chunking type of processing, where you see here every 5 seconds I generate a new window on which I do some aggregation. I can also have something that is a sliding window, here a unit of 5, but it moves every 2 seconds. And finally, also something like a landmark or a rubber band type of operator. So all this can be reflected in the system that we are using at Cisco as a raw stream, where the SQL is very similar to create table statement. Here you have all these different attributes, and you can have a user-defined or system-provided timestamp, and you can use insert and copier commands to populate this type of data. Now comes the new concept, the continuous query. So you operate on these windows over the stream, in the sense like these mini tables that are created every so often. And every so often in this case means every 10 seconds you get a chunk of 5 minutes of data. So this is a sliding idea. So this is kind of the syntax as it's used here. In the brackets, you see the actual new part. The rest is more or less traditional SQL, standard SQL. Derived streams are nothing but a continuous query with a name. And you can build chains or workflows of these kinds of streams. You see here a raw stream, which is the source, which is the actual metrics. And it leads into other derived streams that do, for example, aggregation over time, aggregation over location, aggregation over whatever. That's the beauty of databases. You can use them for everything, including metrics. Finally, here are the syntax, how you would define such an object, a continuous query with a name. We call it derived stream in the system we're using. Notice that we can store these things, or we can leave them in flight, in a sense, like a in-memory computation. This is the idea of this continuous on-the-fly transformation. And just to visualize these two ideas of a time dimension and a location dimension here represented with certain derived stream names. They spring all from this one raw stream. It could be several raw streams that we process at the same time. Using SQL, this is how it would be represented if you would type it into the PSQL console. So I would just want to mention that our system that we have at Cisco is 100% compatible with Postgres. It's a complete superset that has stream processing capabilities. It is very scalable. It deals with hundreds of thousands of events per second, depending, of course, on the workflow, depending on how many streams you're dealing with. And this is original technology from Teresa that was acquired in 2012 and has been used in a lot of products at Cisco, from mobility data, retail data, events, security, emails, other things. So why not use it for metrics in OpenStack or in the cloud in general? So the beauty of the system is that since we're dealing with SQL only, we can leave the optimization to the database, the query optimization, the heavy lifting of deciding what indexes should be used. Maybe in this system it's a little simple because the schema is very simple, at least for the raw stream. But we certainly have the benefit of all the tools, all the facilities of Postgres that can be used. L3 data types for representing these hierarchical names for metrics, HStore to represent key value pairs. Persistence is optional, so you can decide if you have a very high granularity. You can optionally store all these things, also if it's low granularity, but you may want to keep things around, store them somewhere, put them into eventually HDFS and do some backend processing. With Hadoop, for example, we provide stream joins, different types of notions, and it would take another hour to go into all the capabilities that we have, and also innate capabilities for pattern detection, where we can look at very specific things. When the CPU goes up, I want to know how long does it take until the CPU goes down again, and correlate things internally as part of one SQL statement. Very efficient, and we can embed, of course, user-defined functions using R to do machine learning on the fly. So this is a very interesting technology that I wanted to mention here. There are related talks at this summit. They are listed here that go more into what we actually do with a system like this, but this is just one alternative, one technology to process data in real time. There are other, of course, open source types of technologies that are being mentioned. Thank you very much.